morning, students. Today we will be studying chapter 1, electric charges and field. The topic covered is charge and Coulomb's law. You must have observed when we comb our dry hair, sometimes we hear a sound. Also, you must have observed that when we sometimes sit on a plastic chair wearing woolen clothes and suddenly somebody comes and touches us, we get a small momentary shock. These observations led to the discovery of a phenomena called charging by friction. This phenomena of acquiring charge by bodies due to rubbing with each other is called frictional electricity. It was observed by philosopher Thales about 2500 years back, and later on Gilbert and Benjamin Franklin also worked on it and gave their theories. Similar observation is when a glass rod is rubbed on a silk cloth, so the glass rod acquires positive charge and the silk rod acquires negative charge. This is basically due to flow of charged particles. These charged particles were named as electrons by Benjamin Franklin. By convention, it is believed that the particles which flow from one body to another are electrons, whereas the protons, they stay inside the nucleus and their movement is not that observed. Of course, when some electrons get transferred from glass rod to silk cloth, the silk cloth has excess of electrons due to which it acquires negative charge, while the glass rod has a deficiency of electrons due to which it acquires a positive charge. Here, conservation of charge is followed because the amount of charge lost by the glass rod is equal to the amount of charge gained by silk cloth. There are many more examples in which two objects are rubbed with each other and they acquire charge. This phenomena and this branch of physics in which the bodies acquire charge is known as frictional electricity or static electricity. Static because these charges, they cannot flow from one point to another. They stay with the body and they again get transferred when the body comes in contact with any uncharged body. In this picture we observe when a glass rod which is rubbed with silk is brought closer to another glass rod which is rubbed with silk, a force of repulsion acts between them. Similarly, when a glass rod rubbed with silk is brought closer to an ebonite rod rubbed with a fur or woolen cloth, there is a force of attraction between them. This proved that various objects, when they are rubbed with each other, they acquire different charges. The two types of charges, of course, were named by Benjamin Franklin as positive charge and negative charge. A table showing the charge acquired by a particular body when rubbed with another body is shown for reference. In this picture we see an instrument known as electroscope and sometimes as gold leaf electroscope, which is used for detecting charge on a body. It can also identify the type of charge acquired by the body. Sometimes it can also be used for measuring potential difference. The essential parts of an electroscope are the knob. It can also be a circular disc. At the other end of the knob there are two metal leaves which can be of gold or aluminium. These leaves, they are placed inside a glass jar, and the opening of the glass jar is closed with a cork or a stopper. As the gold leaves are extremely thin conducting foils which have low mass per unit area and are flexible, therefore they respond very quickly to small electrostatic forces. The same purpose can be served by aluminium foils also. In the first picture we see an uncharged electroscope, and suppose a negatively charged ebonite rod after acquiring charge is touched to the knob of the electroscope. The charge flows to the uncharged leaves and they also acquire the same charge as the ebonite rod. By property of charges, like charges repel each other, we will observe a divergence in the gold leaves or aluminium leaves. Since here we have touched the ebonite rod to the knob, here the charging is done by conduction, because we have brought two objects in physical contact with each other, that is the ebonite rod and the knob of the electroscope. Another way of inducing charge is if instead of touching the ebonite rod with the knob, we just bring the ebonite rod closer to the knob. Then the negative charges present in the knob, they flow to the other end, that is towards the leaves, and again the leaves acquire negative charge, and due to their acquiring same charge, they repel each other. Here we have induced charge because we haven't brought the ebonite rod in contact with the knob. Of course, again, if we take away the ebonite rod, the leaves become neutral and the divergence will also go away.